right, at this point in our unit, we are moving on to our second big idea. We're moving into probability. Knowing about the probability helps us to compare events to solve problems and understand the real world. So demonstrating an understanding of how likely it is that something is going to occur. To demonstrate an understanding of the possible outcomes, what is possible, and from that, in theory, theoretical probability of what is the likelihood of that event. How likely is it that that actually will occur? This is lesson 6 in your unit. All right, we have Jamie and Alexis, who are playing predicting products. Products, remember, are the answer after multiplication. So they are taking turns to roll 2 dice. Each is labeled 1 to 6. If the product of the two numbers, so when they multiply them, is odd, Jamie gets a point. If the product is even, Alexis gets a point. The first person to get 20 points wins. Who do you think is more likely to win? Well, we need to determine the possible outcomes and then the theoretical probability of each. All right, so here's one way to help predict the winner. Organize the possible outcomes into a table. Each number on the die has an equal chance of being rolled. It's not more likely that you will roll a 3 or a 2. It's an equal chance. So if you rolled a 1 and a 1, the product would be 1. If you rolled a 1 and a 2, the product would be 2. 1 and 3, 1 times 3 is 3, and so on. So these are the possible products that could have been reached. Altogether, up to 6 times 6, there are 36 possible numbers, so 36 possible outcomes. The outcome does not have anything at all related to how likely it is. It just means what is possible. So what can we get? We can get from 1 to 36 the numbers that we have listed here. We cannot get 13, for example. 13 is not a possible outcome. There are 27 outcomes that are even. So if we wanted to, we could circle all of the even outcomes to determine how many are even. Here the entire row is even. Again, every second row it appears is even. We can determine there's going to be a bit of a pattern there. 10, 20, 30. Remember, an even number ends in 2, 4, 6, 8, or 0. So there are a large number of even products, and as we said, there are 27. So we would say that 27 out of 36 is the theoretical probability that we will end up with an even outcome. 9 are odd. We've only got 9 odd ones here. So theoretically, 9 out of 36 outcomes will be odd. When we discuss probability, we make it into a fraction. In theoretical probability, it's always the number of favorable outcomes, so what you want. So in this case, it was even. So there's 27 even possible out of the total number of possible outcomes. In total, there were 36 different numbers we could get. That's our bottom number. The probability of getting an odd number was 9 out of 36. We also make that into a fraction. 9 odd, so that's the number of favorable outcomes, the number that we want. 9 out of 36 as our total possible outcomes. 9 out of 36 is our theoretical probability of getting an odd number. In theory, if we were to roll the dice 36 times, 9 out of those 36 times, we should get an odd number, in theory. So it is more likely that you're going to end up with a even number, because we can see that there are more probabilities or more even outcomes. So 27 out of 36 is larger. There's more likely chance that you are going to end up with 30 with an even number. So it's more likely that Alexis is going to be the winner of this game. Reminder of a couple of things. An outcome is one result of an event, or an experiment. Tossing a coin has two possible outcomes. You can have heads or you can have tails. Rolling a dice has 6 possible outcomes. You can have 1, 2, 3, 4, 5, and 6. The number of outcomes does not tell you what is more likely or less likely, just what is possible. Theoretical probability is communicated in a fraction, must be in a fraction, no longer in words. In grade 5 you worked on words, more likely, less likely. At this point you are expected to be more specific and put it into a fraction form. The fraction comparing the number of outcomes that you want. So the top is always what you want as opposed to the total number of possible outcomes on the bottom. From this we can determine what's more likely to happen and we can make informed decisions. So if we were looking at that game that Alexis was going to play with Jamie, we could say, okay, yeah, Alexis, great job. You play that game. Jamie, I don't know. If I were you, I might not play that game because there's a pretty good chance I'm going to be losing it. Let's take a look at another example. We have a jar that has 5 blue marbles, 6 red marbles, 7 green marbles, and 7 white marbles. Without looking, blindfolded, eyes closed, whatever, he picks a marble from the jar. He's picking a marble at random. There's no way of knowing which one he's going to pick. What are the possible outcomes? Well, you could end up with a blue marble, a red marble, a green marble, and a white marble. What is the theoretic probability of picking a green marble? Well, each marble has an equal chance of being picked. So how many marbles were there all together? Well, there was 5 and 6 and 7 and 7, so a total of 25 possible. So that becomes our bottom number. The favorable outcome is green. So how many green are there? 1, 2, 3, 4, 5, 6, 7. There were 7 green marbles. That becomes our top number. So 7 out of 25 is what we would say is our probability, our theoretical probability of picking green. If we were to pick marbles 25 times, we should, in theory, pick green 7 of those 25 times. We could continue this with each and every color to determine which one is most likely. Let's say we were looking at blue. Again, we know there's 25 marbles in total. 1, 2, 3, 4, 5. 5 out of 25 is blue. This was green. Let's look at white. Again, 25 is our total. 1, 2, 3, 4, 5, 6, 7 white. Red. 25 was our total. 1, 2, 3, 4, 5, 6 red, and blue we've got already. So what would you choose then? Based on knowing the theoretical probability of all of our marbles now, which one would you most likely pick? Which one should you not pick? Well, we can see that green has 7 out of 25, white has 7 out of 25. They have an equal chance of being chosen, and in theory they have a better chance of being chosen than blue or red because there's fewer of them. So if I were betting on this with someone, I would pick probably white or green as the marbles that I think are likely going to come out. All right, your turn to practice. Take a look at this set of cards. How many possible outcomes are there? What are they? And what is the theoretical probability of getting a tree if you were to flip these over and pick a card? Take a moment, press pause, and figure out those answers. All right, let's take a look. How many possible outcomes are there? Well, there is this recycle bin. It looks like compost bin, and there's 2 of those, so 2. Trees, there's 3 of those, so 3. Recycle signs, there's 3 of those, so 3. How many possible outcomes altogether? Well, 3 plus 3 is 6, plus 2 is 8. So there's 8 possible outcomes. What are they? The recycle sign, the compost sign, and the tree. So there are 3 things that we can get. The theoretical probability of getting a tree, well, in total we know there are 8 cards, so that makes our bottom number. Our bottom number is the total. The number of trees, well, we've got 1, 2, 3 trees, so that becomes our top number. 3 out of 8 is our probability of getting a tree. If we wanted to continue, we could say, okay, well, for the recycle signs, there's also 3 out of 8 likelihood for, theoretically, for getting a recycle sign. For the compost sign, there's only 2 out of 8. So if you were to be asked, which one do you think is our best bet for a choice, compost sign, not your best bet. Recycle sign and tree are equally as likely. Either one of those would be a good choice. All right, now you get to go practice. You're practicing determining the possible outcome. So what is possible? How many possible outcomes in total? And with that, determining the theoretical probability of an event. So remembering that the theoretical probability, the bottom number is the total of possible outcomes all together. And the theoretical probability is how many of the item that it is that you want. Page 273 to 275, numbers 1, 2, 4, 5, and 8. If you have questions as you go along, please remember to ask.